Hey guys, welcome back to AlgoYogi. We are now doing stack series, and our next problem in the list is evaluate reverse polish notation. Let's go to LeetCode and give it a read. You are given an array of strings, tokens, that represents an arithmetic expression in a reverse polish notation. Reverse polish notation, if you want to read it out, like you can, but it basically means that like two integers or two numbers will be given to you, and then the operation will be given to you. So you apply that operation between those two numbers. You basically apply, you keep the first number first and second number second. So that's how you apply the notation, and we'll see how we do that. So evaluate the expression, return an integer that represents the value of expression. Cool. Valid operators are plus, minus, multiply, divide. Each operand may be an integer or another expression. Makes sense? The division between two integers always truncates towards 0. There will not be any division by 0 because that's invalid. The input represents a valid arithmetic expression in a reverse polish notation. The answer and all the intermediate calculations can be represented by 32-bit integer because it means like our answer will be in the range. So these are the tokens that are given to us, and this is the way we will be basically calculating our answer. We will be applying all the expressions given to us, all the operands given to us on the numbers. So here, if you can see right here, these are the list of tokens that we need to do. And in reverse polish notation, what really happens is we're gonna go over our tokens from left to right. We'll go over tokens from left to right, and then if you see like two numbers, just basically know that you have two numbers in reserve, and whenever you come across an operation, basically like an operation sign, plus, minus, division or multiplication, then you basically take these two numbers and apply that to both of them in middle of them. So 2 plus 1, that will be 3, but then this is already used. What is left is 3 and basically our multiplication sign. So this is now, these two have been calculated and we have just stored it again right here. Then these are our next two numbers in the line. This is our next operation. Then we will apply this operation in between these two numbers, and this will be my answer. So if you can see right here, like why stack would be the perfect data structure to solve this problem. It's because you keep appending to your stack. So that's what I'm going to do. We will have a stack. We will have our stack, and whenever you see an integer, append that to your stack. And I will convert that to integer before I'm appending it, so that I can directly, whenever I come across any of the operations, so this time it's plus, I will pop these two out, apply this operation. So first number I pop out, stack -1 and stack -2. And if I'm accessing basically my stack and I'm seeing an operation, then I think it's given in the problem statement that we will basically be our input will be valid. Basically all the operations will be valid, and the calculated answer will be in can be represented in the 32-bit integer format. So I will take these two out. I can assign them to, let's say, A. I can assign them to B and A. So this is B and this is A. Now A plus B, and I will again push that to my stack so that I can move forward, and this particular calculated integer could be used my next value in my operation. So this is what will happen, if you can see right here. So let's clear this up. I'll have my stack. Oh my god. Yes, I'll have my stack. Push 2, push 1, seeing a plus, pop both of these and then add them together and then push them back to the stack. So 3, then next number 3, you see an operation, pop both numbers, multiply them because that's the sign is multiplication, so push 9 and you will return whatever is on stack 0 or stack -1. Both are same in this case, because at the end of the day, once the answer Polish notation is calculated, then you basically return whatever is left in your stack. All right, so this is going to be a big of n time complexity solution, because because that's the number of token n. So big of n time complexity, and space complexity could also be, worst case said to be n, since we have our stack that will be storing. But I guess, like, since it depends on, you might just see all the operations in the end, then this would be that worst case where you'll be appending all the numbers and then some things equal number of operations basically, or like half number of operations, because you do that with 2 numbers. All right, so let's go to code editor and write the code. It's quite simple. So I'm gonna zoom in. All right. Okay, I was just trying something. Anyway, let's start writing. I'm going to have a stack which is going to be empty in the beginning. Then I will have my for loop going over each token. So I'm gonna say token in tokens, and if basically the number that I see, basically the token that I'm seeing dot is digit, that's how you check. If it is digit, then I want to append it to my stack. So stack dot append token, and let's convert that token to int before we append it. So token. Then another case is basically I am seeing basically an operator, right? So what I'll do is I'll take out the numbers A and B. So A stack dot pop, and that will be, actually I'll say it will be B stack dot pop, and A will be stack dot pop. So these are the 2 numbers that I have. Remember, this is on the top of the stack, and this is basically on the second top, I would say, just right below the top element. So I will append the value after calculating this using this token, the current token that I'm seeing. It's an operation, so depending on what kind of operation, I will basically will just say. So I think we need to check if token equals to plus. So there will be basically 4 cases. So I'm going to have, first case is stack dot append. What do you append? You basically A plus B, this is what you append. And let's do this based on all other, and then finally there will be an else case. Okay, so what I'm gonna do is if this is plus, then add both numbers. If this is minus, then we will be basically doing a minus B, right? I think that's what was told to us, and that's how this reverse Polish notation works. And if there is a multiplication, then you will just multiply them. So a minus B, and then you will multiply these. Last thing is you divide. And basically we were told in the description that division between two integers always truncates towards 0. So if there will not be any division by 0, so if token or I don't think token, I think the value I'll be dividing my a is by b, dividing a by b. So I'll just check if b equals to 0, b equals to 0, or I think we can just say even a equals to 0 as well, because no matter what you divide, you will basically get 0 anyway. So if you divide some 0 by something, then you should be getting 0. But I think there will not be any division by 0. So are we expecting that there will never be a 0 in a situation where 0 is dividing? I guess let's try out. But let's say if b is equals to 0, we don't want to do anything, so we'll just continue. Else I will basically divide a by b and append it. Okay, awesome. It's too much code right now. And then finally we can just return the stack 0. Okay, I already zoomed out so you can see the code. Let's try to run it. So right now it's not taking the negative digits into consideration, so we are going to strip away the negative sign from the beginning of any digits. So the function, the inbuilt Python function for that is left strip, and just provide the negative sign as string input, and then we can do basically again digit check. So I think this should be good. And one more thing is, when we are doing a division between a and b, we want to actually just truncate it towards 0. So I think this should be good. And I guess problem should take care of this particular condition where we are never dividing by 0. But anyway, we have a check. Let's try it now. Okay, and is it this particular statement? Also, let's have else elifs, because we have like multiple conditions, so that's like kind of necessary to have. Other than if and else, multiple conditions needs to be checked. If otherwise it will just if that doesn't match, it just executes the last one. Okay, so let's submit it. Not super energetic today. Anyway, okay, let's write down the time complexity, big of n, and same as space complexity. N is the number of tokens. You can name it T also. Alright, so let's go back to AlgoYogi, mark this all. See you guys later in the next problem. Bye bye.